In the compound shape above, A is a sector, B and C are congruent angles, and D is semicircle. Determine the size of angle X. So here we have angle X, and our goal is to determine the size of angle X. Now notice we have here, we have a straight line. So if you notice here, this right here is, so if we look at this line, right? Let me draw it again. So erase all link. So let me use the highlighter. Okay, so if we look at this line that is highlighted, right? If we look at this same line that's highlighted, that line that's highlighted is a straight line. And if we notice carefully, we have this angle, which measures 55 degrees, and this angle, which measures 55 degrees, and we also have angle X, right? Now, all three of these angles are at this point, okay? And so if we notice, we have three angles, this angle, this angle, this angle, and they're on a straight line at a common point. Now, what do we know about angles on a straight line at a common point? Well, angles on a straight line at a common point, these must add up to 180 degrees. That means that 55 plus X plus 55, these three angles must add up to 180 degrees. And so that means if you want to figure out the size or the measure of angle X, we have to add 55 and 55 and take that sum and subtract it from 180 degrees. And so that's what we're going to do. So X is equal to 180 degrees minus, we have 55 plus 55, and 55 plus 55 is definitely 110 degrees. So we have that 180 degrees minus 110 degrees, and 180 degrees minus 110 degrees is equal to 70 degrees. So X is equal to 70 degrees. Next, we have part B, which says using pi is equal to 22/7 when necessary, calculate the areas of the following. Sector A. So we need to figure out what is the area of sector A. And so let's show the sector of a circle. So we have this sector, and a sector is just a piece, right? A piece of a circle, right? Sector of a circle. And so we have this sector of a circle, right? Which we have here. Now, how do we calculate the area of the sector of the circle? Well, the sector of a circle is going to be, the area of the sector of a circle is equal to theta over 360 multiplied by pi r squared. Now, what is theta? Theta is the angle. So the angle here is 70 degrees. And what is pi? Well, pi is 22/7. And r, well, r is the radius. And the radius here is 9 centimeters. And so we substitute those values in. So we have 70 degrees for theta. We have 22/7 for pi. We have r is the radius, right? That's 9. And so we have 9 squared, and 9 squared is 9 times 9. And 9 times 9 is 81. So we have 70 over 360 multiplied by 22/7 multiplied by 81. Now what we're going to do here is we're going to multiply 70 times 22. And 70 times 22 is 1,540. Then we have 360 times 7. And 360 times 7 is 2,520. And then we take 81 and we express 81 as a fraction. So we have 81 over 1. Next, what we do is we take 1,500. Next, what we do is we take 1,540 and we multiply that by 81. And when we take 1,540 and multiply it by 81, we get 124,740. Then we take 2,520 and multiply it by 1, which gives us 2,520. Next, we divide these two, and when we divide these, we get that our answer is 49.5. And so that means that the area of the sector of this circle is 49.5 centimeters squared. Next, we have to determine the area of triangle B. And so where's triangle B? We have triangle B, right? Let me highlight it. So this right here is triangle B. Okay, so we have to determine the area of this triangle. Now, what do we know about this triangle? Well, what we do know is that this angle right here is 55 degrees. We also know that this length, one length of one side, or the length of one side of this triangle is 4 centimeters. And we also know that the length of this side is 9 centimeters. And so we have that the area of the triangle, we can use this formula. The formula of the area of a triangle, one of the formulas that we could use to figure out the area of a triangle is AB multiplied by sine C. All right, so in this case, we say that A would be 4 centimeters. We say that B is going to be equal to 9 centimeters. So we have 9 here, and we have sine C, sine of the angle in the middle right there. So this is going to be this angle C, right? So that's 55. And so we have to take 1 over 2 and we express it as a decimal. So we have 1 divided by 2, and 1 divided by 2 is 0.5. And 4 times 9, well, 4 times 9 is 36. And so we have 0.5 multiplied by 36 sine of 55. And so what do? Well, we say, what is 0.5 multiplied by 36? Well, 0.5 multiplied by 36 is 18. So the area of a triangle is equal to 18 multiplied by sine of 55 degrees. Now, what is 18 multiplied by sine of 55 degrees? Well, 18 multiplied by sine of 55 degrees is equal to 14.7447368. Now, if we would express this correct to 2 decimal places, well, we know that this number here is 4. Once it's less than 5, we cannot round up, so we just write 14.74, and that's the area of the triangle correct to 2 decimal places. Next, what we need to do is we need to determine what is the total area of the compound shape. Now, what do we know? Well, we know, so far we know that, we know what is the area of the sector. We already know it's the area of the sector, so we know what is that area. We know it's the area of B, we figured that out earlier. And B and C, they would have the same area, and we know that they would have the same area because if we notice, let's go back. If we go back in the question, they said that, let's go back. They said that B and C are congruent triangles. And so since they are congruent triangles, that means that their areas would be the same, okay? And so we know that, let's move forward. We know that the area of B and the area of C, right? The area of B and the area of C would be the same because these two are congruent triangles, so their areas would be the same. Now, what we need to figure out is we need to figure out what is the area of this semicircle, right? Semicircle D. All right, so we're gonna figure what is the area of this semicircle, all right? Now, the area of a semicircle is given by the formula pi r squared divided by 2. We just take the area of a circle and divide it by 2, all right? Now, what is r? R in this case is going to be, which is the radius. R is 4 centimeters because if you look here, the radius is 4 centimeters. So 4 centimeters. That's going to be R, the radius. All right. Now, what is pi? Well, pi is 22 over 7. And so that means that we are able to substitute these values into our formula and answer the question. So like we said, pi is equal to 22 over 7. That's pi. R is equal to 4, so it's r squared, and we have over 2. So we put r squared over 2, and we multiply it by pi, okay? And so let's simplify. We have 4 squared, and 4 squared is 4 times 4, and 4 times 4 is 16. So we have 16 over 2, and we have 22 over 7. So we have 22 over 7 multiplied by 16 over 2. Next, we say 22 multiplied by 16. Again, we say 22 multiplied by 16, and 22 multiplied by 16 is 352, or 352. Next, we say 7 times 2, and 7 times 2 is 14. And then we divide these two, and when we divide these two, we get 25.14285714. Now, if we were to write this correct to 2 decimal places, it's going to be 25.14 centimeters squared. Next, we are going, in order to figure out the total area of the compound shape, we're going to add the area of B, the area of C, the area of A, and the area of D. The area of B, we figured that out, that's 14.74 centimeters squared. The area of C, that's this area. It's going to be the same thing. They are congruent triangles, 14.74 centimeters squared. The area of A is going to be 49.5 centimeters squared because the area of the sector. and the area of D is equal to 25.14. And so if we add these together, we get that the total area of the compound shape is 104.12 centimeters squared. And that's the answer to this question. The total area of the compound shape is 104.12 centimeters squared.